Hello and welcome. Designers are partially responsible for setting limits to the maximum deformation or elongation that a material may experience due to the action of a load. In the vast majority of the cases, this deformation must not be permanent. This is usually referred to as elastic or reversible deformation. When we work as designers, we set limits because it is undesirable to have materials expanding or contracting more than necessary or breaking into pieces. This is because such deformations may compromise a proper lining up between structures and lead to equipment damage or catastrophic incidents, just to cite a few. Therefore, it is highly desirable that a deforming material recovers its original shape. This ability is usually referred to as elastic or reversible deformation. So, for a rod deforming reversibly, how can we find its maximum length when its maximum deformation is given by specifications? I will show you how to solve this problem. First, sketch the most relevant information about the problem. Remember, sketching is a fundamental engineering skill that allows us to translate our thoughts into reality. Good engineers never miss the sketching part. We need to establish the first condition to this problem. As a designer, I would like this route to work only when there is a direct proportional relationship between the stress and strain, or in simpler words, when stress versus strain is a straight line. A second condition would be the most simplistic scenario, where only the load attached to the rod is acting downwardly as a tensile force without any other effect. For safety reasons, I prefer this route to work far from irreversible deformation. Since the deformation is elastically proportional, the Young's modulus or elastic modulus can help us to solve this problem. Let us use the following data to illustrate this problem. Total elongation, load pulling one of the rod's ends, diameter of the rod, and the elastic modulus, which is obtained from a tensile test using a tensile testing machine or from the literature. Remember, our aim is to calculate the maximum length of a rod deforming elastically. By isolating the variable's length out of this equation and substituting values, we found out the maximum length of a rod deforming elastically and proportionally. Thank you very much for watching, and please subscribe to this channel to support this project. Just click anywhere on this image.